So looking at this question, it tells you those are horizontally and vertically upwards representing. Now, a particle of mass 5 kg initially at rest when t equals 0, u equals 0. At that point, this is position vector. Gravity, so remember g we're going to use minus 9.8, and that's what acts on this, also these forces. Now, in order to put this as a force, you know that force is equal to mass times acceleration. So in this case, this gravity, it acts downwards, and it does not act in this axis. So this force is going to be mass. The mass is 5, and this is moving 0 horizontally and minus 9.8 downwards. Okay, so it's a pull. So this force is going to be, quickly do that, 5 times 9.8 gives me 49. So you get 0 minus 49 is that force. So when we say find the acceleration vector of the particle, okay, so what we need, find the acceleration vector. So I know that is that's that. Okay, so what we got is, before we go through anything, 3 forces, right. So first let's look at the 3 forces that are acting on it. You've got 15 minus 8 plus minus 7 minus 2 plus this force 0 minus 49. So that plus that plus that will give you the resultant force. Again, we're going to use Newton's second law, and that's going to equal mass, which is 5, times the acceleration. We need to find the acceleration vector. So if we add all these together, you'll get 8, that plus that, minus 10, minus 59, equals 5/8. I'm just double checking this. Yeah, that's okay. That's okay. Yeah. So therefore, acceleration vector, divide that by 5, you get 1.6. Divide that by 5, you're going to get 11 minus 11.8. So that's your acceleration vector when you're putting all these forces together. Number 2, now it goes here, find the position vector of the particle after 10 seconds. Okay, and just, okay, so we know that initially it's at rest. We've got the acceleration, we've got 10, we need the position vector. Okay, so what we can do is, now these forces aren't going to change, so it is telling you that this is so that we'll just write it there as U, V, A, T. We need to find what we know that's the initial position. Okay, we need to find the position vector after that. So we find the displacement and the radial to there. So we need to find that. We've been told that it's 0, 0 initially. We've been told that the acceleration is 1.6 minus 11.8, and we've been told that we want to find the position after 10 seconds. So we got S, U, well, we need to find S, we got U, we got A, and T. Okay, so you can use the vector, well, the equation. So that equation, S equals UT plus half AT squared. UT plus half AT squared. So S is going to equal to, well, that's going to be 0. 0 times 10 is just 0, so that's going to go. this one's going to be half times 10 squared is 100 multiplied by this vector. So that's going to give me 50. So 50 times 1.6 is going to give me 80. And 50 times minus 11.8 is going to give me minus 590. But don't forget, this is the displacement. So if we want a position vector of it, it was initially at this point. Excuse me. It was initially there, then it got displaced by this. So it ends up that plus that 82 horizontally, and that plus that minus 545 meters.